Alright, AP, this is our final video or lesson on reviewing Unit 3. Okay, so we've had the stuff over winter break, right? There was 2 weeks that were dedicated to Unit 3 videos off AP Classroom, and then we've now spent, this would be the 4th day, kind of just going over now all the stuff from Unit 3. Okay, so these are the last 2 topics we haven't touched upon yet. Implicit differentiation and inverse functions. If you guys remember implicit functions from last year in Honors Pre-Cal, this was the unit on like conics, circles, and hyperbolas. And if you guys remember, those type of equations weren't necessarily written, we're so used to seeing, right, f of x is equal to, and then the equation in terms of x, and same goes with, y is equal to, and then the rest of the equation in terms of x, right? But what that unit on conics showed us was that you can have implicitly defined functions where you have the x and the y's, in other words, on the same side of the equation representing a graph, right? That was, again, circles, ellipses, and hyperbolas. Okay, so that's what implicit differentiation is. It allows us to take derivatives of those type of functions, okay, or not functions, but graphs. So with that said, okay, let's look at some equations here. Right, and so all of these will be find the derivative with respect to x. Okay, and actually before I continue on there, let me actually write down maybe the, like the steps to being able to do implicit differentiation. Okay, so pause right here on number 1. Okay, and the steps are, this I will take the approach for all of them. Okay, you want to differentiate both sides. Okay, both sides with respect to x. Yes, you're turning in these notes, so make sure you write all this stuff in. Okay, now when you differentiate, you're gonna obey the chain rule. Okay, you're gonna obey the chain rule plus other rules. Okay, so we'll put, I don't know, parentheses plus all other differentiating rules we've covered at this point. Okay, now you're also going to by multiplying, or multiply by dy dx, this notation. Okay, every time you differentiate an expression containing y. Okay, now if you have your differentiating rules down, this concept here or this skill here won't be too bad. Okay, but you need to have, again, being able to take derivatives in the chain rule and so on. You need to have that down. Okay, second step will require you to now isolate dy dx by getting all of the dy dx terms onto one side of the equation and all other terms onto the other side. Okay. Step 3 is factor out dy dx if necessary. So once you have all the dy dx terms on one side together, right, you might need to pull out a dy dx to isolate that dy dx. And then step 4, you would solve for dy dx. Okay? So what does all this look like in practice then? So, continuing on, sorry guys, it looks like it kind of went messy here. Continuing on then, the first example I was writing down right there, okay? We're going to find the derivative with respect to x for this problem right here, okay? Y to the third minus 4y. Make sure actually I'm writing down the right example here. Yes, I am. Y to the third minus 4y, oops, 4y is equal to 3x squared plus 2x. Okay. So again, this equation here, it's written very different than the ones we've been looking at. And if we were paying extra attention to it, then it might remind us to our conics unit from last year. Again, this could be an equation representing a conic maybe, okay? So then, what you would do here is, again, take all the derivatives, okay? You are also differentiating those y terms, okay? But each time you do so, like we wrote up here, each time we differentiate an expression containing a y, we're going to write the dy dx next to it. Okay, so this first one here, y to the third. Okay, so multiply by the exponent, 3y, and subtract 1 to the exponent. So 3y squared, dy dx. Don't forget to write the dy dx after it. Okay, minus 4y. Take the derivative here. If this was minus 4x, right, the x would just go away. So similarly, the y just goes away. So minus 4, again, dy dx. Okay, because I differentiated a y term. It's equal to, now you differentiate the right side, and that's just like we've always done. 6x plus 2. Now thankfully the dy dx's are all together on the left side of the equation, right? And both of those terms have a dy dx. Okay, so I can actually pull that out then. I can factor out the dy dx from both those terms, just like this. Okay? And so then, what's the derivative here? With respect to x, divide both sides by all of this so that I isolate the dy dx then. There you go. Okay, this will be 6x plus 2 over 3y squared minus 4. Implicit differentiation definitely will show up on the AP test. Okay? So that is example 1. Here's example 2. If 3x squared minus x y squared plus y to the negative 1 is equal to 1, find y prime at, Jesus, did I just misspell at? That's terrible. At 1 comma 1. Okay, if that equation there is equal to 1, okay, find y prime at 1 comma 1. I'm just going to switch up the notation here because remember, right, way back there were multiple ways to write a derivative. Okay, y prime right here that they're talking about, this is the same thing as just writing dy dx. Okay, exact same thing. So if I'm going to take the derivative here then, okay, first term there would be 6x, right, because 2 times 3 is 6, subtract 1 from the exponent, so just 6x. Now right here, this is the common mistake students will make. Okay, right there. X y squared. That's technically x times y squared. That's a product. So if I'm going to take the derivative there, this green that I've underlined, I have to apply the product rule. Okay, so if I apply the product rule, then I have that minus there. I'm not going to lose track of them, so I'm going to write them down, but then I'm going to write parentheses, right? And then you take the derivative. It could be the derivative of the first guy or the derivative of the second guy, right? Just make sure you do each one, right? So for this first one, I'm going to do the derivative of y. So I'll leave x alone. The derivative of y would be 2y. Y squared, sorry, would be 2y. Don't forget the dy dx, because I took the derivative of that guy. Okay, plus it's the product rule, right? Now it's the derivative of x. The derivative of x is just 1, so then I'm going to just get y squared there, right? Because I'm going to leave that one alone. Okay, close the parentheses. So I just did the product rule there. Okay, and then finally, I'm going to have this guy right there, the y to the negative 1. And if I take the derivative there, multiply by the negative 1, so negative y. Then I'm also going to subtract 1 from the exponent, negative 2. Okay, don't forget the dy dx, I'm running out of space there. And then that's all equal to the derivative of a constant is just 0. Okay, so equals 0. Okay, now I'm going to clean all this up a bit. So let me see. I got 6x. Distribute that negative into the parentheses. I'm also going to move that 2 to the front, right? Because that's kind of awkward. So 2xy dy dx. Okay. Then the negative goes there too. So negative y squared. And then I got y to the negative 2. I'm going to get rid of the negative exponent by writing it 1 over y squared dy dx, and that's all equal to 0. Okay, so I got two terms with dy dx, right? So I want those together on one side of the equation, okay? Because right, these two right here, I'm going to be able to factor out of dy dx like I did right here in this problem. So I want these two terms together, so then that means I need to get rid of these two terms, the 6x and the negative y squared. So I'm actually going to go ahead and send those over to the right side. Okay, so I'm going to get, so if I subtract 6x from both sides, right, I'll write it out just so you guys don't get confused. Okay, so that guy goes away. Then I'm going to add the y squared. So these guys go away. Got to add it here too. Okay. Now I have negative 2xy. Let's see. Yeah, dy dx minus 1 over y squared dy dx is equal to negative 6x plus y squared on the right side. Now I can pull out the dy dx. Alright, I'm going to factor all that out. Okay, and then now I can divide both sides by all of this right here, so I can isolate the dy dx. So, Jesus, so let me see. So I gotta use the other paper if I don't want to. Okay, so if I divide both sides by dy dx, sorry guys, let me organize this wire here. Okay, I'm gonna get, let's see, all over negative 2xy minus 1 over y squared, right? Now, remember that the original problem said if all of this, right, find y prime at 1 comma 1. So we need to find the derivative at that point right there. Well, we found the derivative already. dy dx is all of this, right? So if we're finding the derivative at, like they said, 1 comma 1, and all we got to do now is just plug in the 1 comma 1, right, the x comma y, plug it into all of this, and then just, you know, simplify everything basically. Okay, and if I do that, let me see, so you could say dy dx at 1 comma 1, right, you start plugging in negative 6 times 1 plus 1 squared all over negative 2 times 1 minus 1 over 1 squared. Just clean this all up, so you'll get negative 6 plus 1, you get negative 5 in the numerator. Down here you'll get, so all of this is negative 2, and it looks like minus 1, so negative 2 minus 1 would be negative 3, and then clean that up, right, negative over negative, then the derivative at 1 comma 1 for that implicit equation is 5/3. Okay, that's the slope of the tangent line at 1 comma 1 for that equation. Okay, next one, let's take a trig function. So find dy dx for y is equal to cosine xy. So find dy dx for y is equal to cosine xy. So if I differentiate both sides here, then the derivative of y, right, is 1. It's a linear variable, right, just like the derivative of x is 1. So if I take the derivative here, then this would be dy dx is equal to the derivative of cosine is negative sine, right, so xy, times the derivative of the domain here of the trig function. So the derivative of xy. Now xy, again, that's a product. Okay, that's a product. So you have to do the product rule of derivatives there. So then the derivative of y, of xy, right? I'm gonna take the derivative of y first. So x dy dx plus then the derivative of x. So then that's just y. Okay. Close the bracket there. And it looks like from here I can maybe then just distribute the negative sine xy into both terms. Yeah, that looks like maybe the easiest thing to do there. So then that'll be have an x there, right? So negative x sine xy dy dx. Then I have the y. So negative y sine xy. Okay. Next, I'm gonna take this term right here and add it over to the left side, right? Because it's minus. So I'm gonna add x sine xy dy dx to both sides. Okay. And what that will do is I'll now have dy dx plus x sine xy on the left side. So then that's equal to, whoops, forgot my dy dx, sorry guys, dy dx equal to, and I still had this guy on the right side. So he stayed there. Again, I had decided not to show the work, but then I'm thinking like, no, I don't want to lose anyone. Again, I added to both sides. Okay. Now this allows me to pull out a dy dx from all of this. So if I pull out a dy dx from this, I have 1 plus x sine xy, right? Because I pull out a dy dx from both these terms. That's equal to negative y sine xy. And finally divide by all of this. So then my answer, the derivative there will be negative y sine xy all over 1 plus x sine xy. Boom. Okay, so we'll take let's do some more examples just like the ones we did, just to further reinforce what we were doing here. Okay, so let's find dy dx. So I mean the actual, whoops, I put 1, this is number 4. Find the derivative with respect to x, and here is this function, x to the 5th plus 7x is equal to 5y minus 3y to the 3rd. Okay. So then if I take the derivative here, this first term will be 5x to the 4th plus 7. That's equal to, right here, the derivative of 5y would just be 5 dy dx. And then right here, negative 9 y squared dy dx. Right here, straightforward, right? I can pull out dy dx from the right side. Like that. Factored it out on the right side. And so then divide both sides by 5 minus 9y squared. I'm going to write the dy dx first, just a notation thing. But then that'll be 5x to the 4th plus 7 over 5 minus 9y squared. Okay. Number 5 says if x to the half plus 1 is equal to y times 1 plus y to the 1/2, find the derivative, find y prime, right, or dy dx, same thing, at 1 comma 1. Now those 1/2 powers, those rational exponents you see, right, 1/2, that's just radical, right? It's radical x. Okay, so if I take the derivative here, let me see, I'm trying to think what's the fastest way to go about this. Yeah, I think, well, I'm noticing this right side looks complicated right now, right? So I'm actually going to go ahead and distribute that y in first. So if I do y times 1 is y. Now y times y to the half power, right? 1/2. This is really like having y to the 1 power. So y to the 1 times y to the half, right? Properties of exponents. Right here, I'll add your exponents, so 3/2, right? Product rule of exponents. 1 plus 1/2 is 3/2. And then now I'm going to proceed with the derivative then. So multiply by the exponent, subtract 1 from the exponent. The derivative of a constant is 0, so the 1 goes away. The derivative of y is 1, so dy dx, because I again derived y. And then right here, multiply by the exponent, subtract 1 from the exponent, and that was the derivative of y, so dy dx. Let's see, on the right side I can pull out a dy dx, right? Now on the left side I'm going to go ahead and use get rid of the negative exponent, right? So you send it to the denominator, and I'm also just going to go ahead and use radical form. Okay, so again, I send it to the denominator to get rid of the negative exponent, and then I'm going to switch it over to radical form. On the right side, same thing is happening. I'm pulling out a dy dx. So that's just 1, right? If I pull out a dy dx plus, that's y to the half, so square root of y, that'll be 3 square root of y over 2. Yeah. Okay. And then I can divide all of this, by this that's in the bracket here. Okay, so if I do that, let's see, I think at some point it maybe makes sense. I mean, we're almost at the derivative to start plugging in your x and y values, but I'm just gonna go ahead and keep powering through all of this. So I have 1 over 2 square root of x all over 1 plus 3 square root of y over 2. That's dy dx. And this isn't even, I need to combine the denominator before I can apply the complex fraction rule, right? So I'm actually, now that I pretty much found the derivative, right, even though it isn't cleaned up or anything, I can go ahead already plug in my x and y values and see what all this reduces to. Okay, so dy dx, right, at 1 comma 1 will be 1 over, both x and y are 1 and 1, so 2 square root of 1 over 1 plus 3 square root of 1 over 2. So 1 over square root of 1 is 1, so 1/2. Square root of 1 here is 1, so then it's just 3 over 2, so 1 plus 3 over 2. So 1 plus 3 over 2, okay, please don't let your fractions fail you here. Okay, 1 plus 3 over 2 will be 5 over 2. Okay, apply the complex fraction. When you have a fraction divided by a fraction, multiply reciprocal. Okay, multiply reciprocal. 1/2 times 2 over 5. You learned this way long ago. If you divide by a fraction, multiply reciprocal. Okay, and so this will be 2/10, which simplifies to 1 over 5. Okay, so the derivative of that equation at 1 comma 1 is 1/5. The slope of the tangent line for that equation at 1 comma 1 is 1/5. Okay, next let's do another trig function, then we'll pivot to actually a free response style on implicit differentiation. I think by then, I hope that, you know, I've done a good job of having you guys understand this. So find dy dx for y squared is equal to x cosine y. So take the derivative of both sides. The derivative of y squared will be 2y dy dx. That's equal to, now x cosine y, this is x times cosine y. That's the product rule. Okay, so first thing is take the derivative of, I'll say cosine y, so then that'll be x sine y. Okay, negative sine y, right? Forgot my negative there. So x negative sine y, and I do have to do a dy dx, right? Because by the chain rule, I would then take the derivative of the inside, and the derivative of y is just 1, right? But it's the derivative of y, so dy dx. Okay? Then plus the derivative of x is just 1, so then just cosine y, because you leave cosine y alone. So then, let's see, I'm actually gonna, yeah, let me just clean it up a bit, because I don't like how I wrote that out by forgetting the negative. So then I'll get negative x sine y dy dx plus cosine y. So all I did was clean it up, move the negative to the front there. These two here have dy dx's, so I want them together. So I'm going to add x sine y dy dx to both sides. Cancel out here. So then I'll have 2y dy dx plus x sine y dy dx is equal to cosine y. I can now pull out a dy dx. So 2y plus x sine y is equal to cosine y. I'm going to start using parentheses here too. And then finally divide by all of this then. And so then the derivative there would be cosine y over 2y plus x sine y. Boom. Cool. Whoops. Okay. So I want to switch over now to a it's like a more free response style of implicit differentiation. Okay. In this particular file I am looking at, it does say it is a free response. I'm using a practice free response, and it does say calculators should not be used here. Okay, so don't use calculators. And question 1 says, find the derivative of the relation x squared y to the third plus 4xy plus x minus 6y is equal to 2. Then write the equation for the tangent line of the relation at 2, 0. Okay. Pause the video if you need to finish writing this in. First step will be, let's do the implicit differentiation. Okay, I've been using green to underline to help you identify where the product rule is going to have to be applied. Okay, this is the product rule because I have two terms here being multiplied, right? X squared and y to the third. So then the product rule says x squared times the derivative of the second one. That'll be 3y squared. You took the derivative of y, so dy dx, plus the derivative of now x. That'll be 2x. You did not touch the y, so y to the third. Okay, plus 4 times, okay, and then notice you have xy. So that right there is the product rule again. Okay, so the derivative of y, that'll be x dy dx, because the derivative of y is just 1, plus the derivative of x, so you get just y. Okay, and the 4 is a constant, right? So I just, sorry, a coefficient, so I just left it there. Derivative of x is just 1, so plus 1. And then the derivative of negative 6y will be negative 6 dy dx. Okay, and then that's equal to derivative of 2 is 0. It's quite long string here. I think I'm going to, let me see. Yeah, let me rewrite this by distributing the 4 in right here in the parentheses. And then from there, we'll be able to continue. So I got, and not only that, I'm going to also move that 3 to the front so it's not awkward here. But I still have the dy dx. So 2xy to the third. And then now I have 4x dy dx. Right? I'm just distributing the 4 in. Plus 4y. Plus 1 minus 6 dy dx is equal to 0. You want all the dy dx terms together, right? So you might be able to factor it all out. So I'm actually going to I'm going to subtract, so I can move these 3 that I just underlined in pink over to the right side. So I'm going to subtract by 2x y to the third to both sides. I'm going to subtract by 4y. And I'm going to subtract by 1. So that goes away, and that goes away. So then I'm going to have 3x squared y squared dy dx plus 4x dy dx minus 6 dy dx. That's equal to everything that I passed over, right? Negative 2x y to the third minus 4y minus 1. And now I can pull out a dy dx, right? So I have 3x squared y squared plus 4x minus 6 is equal to negative 2x y to the third minus 4y minus 1. And now I can divide both sides by all of this right here, right? By this. That'll isolate the dy dx. And so when I do that, I have dy dx is equal to, and I have negative 2x y to the third minus 4y minus 1 over 3x squared y squared plus 4x minus 6. Okay, now they want, so we found the derivative, right? So you'd get points already, at least half the points for finding the derivative. Okay, but they also want the equation of the tangent line. Okay, now again, this represents the slope of the tangent line, and we know that needs to be at what point? 2, 0. That was given to us in the problem. Which means then, plug in your x and your y into all of this. If I plug in, right, notice my y is 0. So then this term goes away, this term goes away, this one right here, all that will go away. And when you do all of that, you should get negative 1 over 2. Okay? And so then, the tangent line, right, you have your slope, negative 1 over 2, and then you have your point, 2, 0. So then when you plug it in, you'll get y minus y1 is 0. So y is equal to slope, negative 1 over 2, x times x1, which is 2. So x minus 2 inside there. There you go. Okay, this would net you full points for that question there. Question 2 in free response says, write the equations for the tangent line and normal line. It's been a while since we do something with the normal line. To the graph of, we have y squared minus 4x squared is equal to 5 at the point negative 1 comma 3. That's negative 1 comma 3. Okay, so then gotta find the derivative first. So if I take the derivative of that right there, I'm gonna get 2y dy dx minus 8x is equal to 0. So I'm going to add 8x to both sides, right, because I'm trying to pass it over there. So I get 2y dy dx is equal to 8x. And then I'm going to divide by 2y to finally isolate dy dx. So dy dx is equal to 8x over 2y, and that'll simplify to 4x over y. Okay, and there you go. That's the derivative. I think this one's more straightforward. We have the point negative 1 comma 3. So then to find the slope of the tangent line there at negative 1 comma 3, all I got to do is plug in here. So negative 4 times 1 is negative 4 over 3. So there's my slope. Tangent line then would be y minus y1, so y minus 3 is equal to the slope, negative 4 over 3 times x minus negative 1, so plus 1. Oops, we're on my desk. Okay, that's one answer. And the normal line, remember what the normal line was? Normal line is the line that's perpendicular to the tangent line at that same point. So then all you got to do is negative reciprocal the slope. Negative 4 over 3 becomes 3 over 4. Okay? There you go. That will net you full points on this question. Last one on the free response. It's find the second derivative, okay, in terms of x and y for x to the third minus y to the third is equal to 4. Now, whenever you're dealing with second derivatives, okay, whenever you're dealing with second derivatives of implicit differentiation, second derivatives and implicit differentiation, you're almost always going to be dealing with at least one substitution. Okay, and you'll see what I mean by this. So let's go ahead, take the derivative like we've been doing now for a while now. 3x squared, right, minus 3y squared dy dx is equal to 0. So we're going to solve for dy dx. Right, so I'm going to subtract 3x squared from both sides. I'll get negative 3y squared dy dx is equal to negative 3x squared. Then I'm going to divide by negative 3y squared. Right? Notice that I have negative 3 and a negative 3, so then when I do this division, the negative 3's will cancel, so then I'm left with just x squared over y squared. Okay? So that's the first derivative. So then to find the second derivative, I got to take the derivative of this now. Okay, a couple ways you can go about it. You can use the product rule, right? If you have x squared times y to the negative 2, it's one way to go about it. Or you have a quotient, right? Function over a function. So you can just do the quotient rule for derivatives. Okay, so then the second derivative, then I'm going to use the quotient rule, okay, tells you the derivative of the denominator, so y squared, so the denominator times the derivative of the numerator, sorry, the denominator times the derivative of the numerator, so 2x, okay, minus, this one is a subtraction, right, the derivative, or sorry, the numerator, and then the derivative of the denominator. 2y, and that is a y, so dy dx. all over dy dx is part of the numerator. Okay, all over square the denominator, so y to the fourth. Okay. Now you'll have to pay special attention here because this is where the substitution comes in, right? Here's what we have so far. One of these terms we already know. Okay? Which one is it? dy dx. That's right here. dy dx is equal to what? X squared over y squared. So I can just go ahead and plug it in. Okay? So it'll be y squared times 2x minus x squared 2y, and then now I'm going to write x squared y squared all over y to the fourth. Okay, now it's pretty messy. Okay, now what you want to do is, this first term is, well, technically, right, 2xy squared. Forgot to rewrite this neater, but that's fine. Okay, minus, and then right here, notice that because of the over y squared, I'm technically going to have a fraction. So I can actually clean all this up. I can get rid of the fraction, right? If I multiply everything on the top and bottom by y squared. Okay? Now, what that's going to do for me is, okay, so I still have that 2, that x, y squared times y squared, I'm going to get y to the fourth, okay, minus, I'm going to move that 2 to the front, x squared. Now y times y squared, no, sorry, right here then, right, y squared, you see how it's in the denominator, times y squared. If I multiply all this right here by y squared, notice that the y squareds are going to cancel out. But you still have this y. This y will stay. So you have that y there. But then the x squared that's still there times this x squared, I'm actually going to make this one here then a 4. Whoops. So when I clean all that up, okay, this second term right here with the y squared, I'm going to get just 2x to the fourth y. Okay, so I'm going to explain it again, what happened. Okay, so I had moved the 2 first, and then I still have that x squared. Okay, now the y squared, and a y squared, the y squareds canceled, so I still have this y, but then I still have this x squared. So x squared times x squared became x to the fourth. Okay, all over the denominator y to the fourth times y squared, y to the sixth. Okay. Yeah, I think that we're getting close. Okay. Let me move over here to the left side. 2x to the y fourth, 2x to the fourth y. I think I can factor out a, let me see, I can factor out a, I think more specifically, let me factor out a negative 2x y. Okay, and let's see what that does. If I factor out a negative 2xy from this guy, a negative 2xy from this guy, I get a negative y to the third. If I factor out a negative 2xy from this guy, I get a positive x to the third. Okay, all over y to the sixth. This in here, right, it's the same thing as writing x to the third minus y to the third. You guys see what all that is equal to? At the very beginning, as part of the problem, they told us this is equal to 4. So I can actually sub all this, right, to be 4. So then this will now be, if I sub that into before, negative 2xy times 4 then, over y to the 6th. Geez. So then, negative 8xy over y to the 6th. You got one y on top, one in the bottom. So then, this is it. Here's the finish line. The second derivative will be negative 8x over y to the 5th. Okay? It's a really good problem. Okay, let me see. How much running time are we at now? 50 minutes? Okay, so very quickly then, to end this lesson, I'm going to talk a little bit about inverse functions and derivatives. So let me find my resource here. Okay, there is a formula for inverse functions. Okay, hopefully, I mean, it was covered definitely in the AP Classroom videos, but to make note of what that was, okay, let me see, where is it at? Okay, the formula we'll be working with, so again, these are the inverse functions and derivatives, is f inverse of x is equal to 1 over f prime f inverse of x. Okay. Sorry, to find the derivative of f inverse of x. So f inverse x prime, to find the derivative, that's what you have to do right there. Okay, that's a formula. So recall, I think the best way to illustrate this would be through an example. Okay, so given f of x is equal to 4x minus 3 and f prime of 2 is 4, find the value of, then we have f inverse of 5 prime. Okay, remember that in inverse functions, the x and the y are switched, right? If you guys remember that. Okay, in other words, the domain and range are switched. So if you have a function f of x, right, it has a domain and range. F inverse of x, the domain becomes the range and the range becomes the domain. You switch them. Okay, so what this says is, if you have f inverse of x here, f inverse of 5, right? Normally you have f inverse of x. That's telling you that the x value is 5, right? But this is f inverse. So then 5 is not the x value. 5 is the y value for f of x, okay? So first step would be 5 is the y value for f of x. Again, you switch the x and the y. So f inverse of 5, that's telling you that's the y value of f of x. So already having f of x, then, if that's the y value, you can do this. You can set it equal to 5. Okay? And so if I solve for x here, 4x is equal to 8, x is equal to 2, then that means 2 is the x value when the y value is 5. So step 3 says then f of 2 is equal to 5. Now I just went full circle with the first step. Okay, if f of 2 is 5, then f inverse of 5 is 2. Right? Switch the domain and range. The x value becomes the y value becomes the x value. Okay? And so then, step 4 is just apply that formula, the one from this one right here. Okay, so then to find the derivative of f inverse at 5, just apply that formula. Okay, so then f inverse of 5 prime will be 1 over f prime of f inverse 5. Whoops, I put prime in here. F inverse, sorry, I put prime. So that's f inverse of 5. F inverse of 5 is what? 2. Okay, that's what this work in step 2 was. Okay, the x value is 2. So then this would be 1 over f prime of 2 then. Okay. Now, f prime of 2, that's easy. You have f of x, that was given. What's f prime of x then? If I take the derivative of 4x minus 3. The derivative here would just be 4. So then f prime of 2, right, there's nothing to plug it into. So that means the y value is 4 for every x value. So then f prime of 2 is 4. So 1 over 4. There you go. Okay? That's probably the best way to illustrate how to do inverse derivatives. Again, there's a formula, yet another formula or another thing you have to memorize. Okay? Yeah, I mean, yeah, I don't know how else to like really explain it to you guys. I mean, I was in your shoes at one point. I know it wasn't virtual, it definitely wasn't, I know, but it was still hard because there was a lot of things you kind of just had to memorize, you know, and there were some proofs and all that I didn't even understand. Like, for example, if we had the time, if we were in class and had the time, I would have shown you guys how this formula comes about. We would have proved it. But again, there's no time, right? We got to synthesize our classes to only about 2 hours a week. So, but yeah, that pretty much wraps it up. I think maybe just doing one example of what this might look like. It only took like 2 minutes. We're at 57 minutes, right? I wanted to keep this at 60. So let's do one quick example. If f of 2 is -5 and f prime of 2 is -3 over 4, find f inverse prime of -5. Okay, same notation of as kind of like what we had here. Okay, exact same thing. So all I'm going to be doing is applying that same formula. Okay, so if I do that, I'm going to have, so again, f inverse of -5 prime, it'll be 1 over f prime of f inverse of -5. Yeah. That's correct, yes. Sorry, just double checking. I wrote the formula down correct. So then, what is f inverse of -5? So the first thing I gotta do here is find it. I'm giving f of 2 is -5. So remember, right? This is the function of f, right? There's the x, there's the y value. So in f inverse of x, you got to switch the x and the y. You switch the domain and the range. So then f inverse of -5 is equal to 2. Okay? So then all I got to do then is just plug right back in here. 1 over f prime of f inverse of -5 is 2. So then 1 over f prime of 2. F prime of 2 is given. It's right here. It's negative 3/4. So then 1 over negative 3/4. Simplify this. Okay? 1 divided by negative 3 over 4. 1 divided by a fraction. When you divide by a fraction, multiply reciprocal. Okay? So then this will be negative 4 over 3. Okay? So it's just using the formula. You guys may stop the notes here. Okay, this is all that's required for you guys to submit for credit. I will go ahead and do one more example. Okay, for those of you that want the additional example on inverse functions here. This one is optional. Okay, if f of negative 2 is 4 and f prime of negative 2 is 2/5, find f inverse of 4 prime. One over, after a while you just, I don't know, just don't forget this stuff. Where do you find f inverse of 4? It's right here, right? This is the function of f. So f inverse would be x value 4, y value, negative 2. Okay, switch them. And so then, plug in, this would be 1 over f prime of negative 2. And that was given right there. So 1 over 2/5. Okay, divided by a fraction, so multiply reciprocal. 5 over 2. Okay. Alright guys, it's a long one, I know, but I mean, this is our class for today. Okay, please submit your notes. Unit 4 begins on Friday. Be ready. Okay, Unit 4 notes are due today and tomorrow. Okay, the grace period is slowly closing. If you still haven't got to those videos, like, that's the poor choice, the poor decision on your behalf. Okay, this is how you get overwhelmed. This is how you start stressing out. Please get to them. Get busy. Okay, bye guys.